Hey guys, and welcome to ArcTech. So in this video we'll see how to create a node and how to allocate memory to a node. Now in C++ to add a node to a linked list, we have to first create a node, then we have to allocate memory to the node, and then only we can add the node to the linked list. So in this video we'll see how to create a node and allocate memory to a node. Now a node of a linked list is always dynamically allocated. Okay, so to allocate a memory to a node, you have to always use the dynamic memory allocation techniques. Memory is allocated from the free store. Now we know that free store is available in the heap store, and heap store is used for doing the dynamic memory allocation. Okay, the objects or elements stored in the free store can be accessed using their addresses. Okay, so to access the elements stored in the free store, that is the elements stored by dynamic memory allocation, can be accessed by using their addresses. And since pointers are used for storing the addresses, hence we use pointers for accessing the elements stored in the free store. Hence, to access the nodes, we'll use the pointers. Now the new operator, okay, this operator is used for allocating the memory dynamically, okay, and this operator will allocate the memory and will return the address of the allocated memory location. So we'll use this operator for doing the allocation of the nodes. Now a node of a linked list is created using structures. Why? Because every node is a structure. Okay, so we will first create the structure and then we will allocate the memory using the new operator. Okay, now node will have two parts. The first part is called the data part and the second part is called the link part, where we store the pointers. So the structure will have two parts. The first part is data part and second part is the link part. We'll see this. Now here we have the code for doing the dynamic memory allocation of a node and creating the node. Okay, now to create a node and to allocate a node, we have to follow three simple steps. The first step is you have to create the structure of the node. That is, you have to write the definition for the structure of the node. Okay, now this will tell the compiler that what are the contents of the node. Okay, after this you have to create a pointer of this structure type. Okay, here you can see that we have created a pointer of this structure type. Okay, after this we have to allocate the memory using the new operator. Okay, you can see here the memory is allocated using new operator and the address written by the operator is stored inside this new PTR. So new PTR is having the address of the newly allocated memory. Okay, now this structure is the structure of the node. That is, our node is like this. Okay, the node has two parts. Okay, now after this we have data inside the data part. So we have only one variable here, that is the data inside this data part. So we have data here. Now we can also use other variables, like we can also use integer, float, character here, but in this case we have used only one variable. Okay, now after this we have the pointer part. We have stored next pointer here. Okay, so in this part we'll store the next. Okay, that's it. So after this, to access the data field, that is to access this data element, what we'll do is we'll just write the pointer name first, then we'll use the arrow operator, and then we'll write the variable name. Okay, so in this way we can access the variable of the node. And to access the pointer stored inside the node, that is to access this pointer, okay, what we'll do is we will first write the pointer that stores the address of the node, then we'll write the arrow operator, and then we'll write the pointer name, that is the pointer present inside this node. Okay, now we can also delete the dynamically allocated node using the delete operator. Okay, for example, to delete a node whose address is stored inside new PTR, we'll write delete and then we'll write new PTR. So in this way we can delete the node using this delete keyword. Now here we have some basic operations that we can perform on a singly linked list. Okay, so we can insert a node at the beginning, we can insert a node at the end, we can delete a node from the beginning, we can delete a node from the end. Okay, we can do traversing, that is we can do the processing. For example, we can display the list and we can also search for the element or data inside the linked list. Okay, so these are the operations that we'll perform in other videos. So in this way we can create a node and we can allocate memory to a node. In the further videos we'll see how to do operations on a linked list. So thanks for watching.